This is project 18 of Hacking with Swift. We're going to learn all about iAd, which is a blessed relief because the last two projects have been awfully hard. And iAd, trust me, is extraordinarily easy. So easy I thought, well listen, this video would be too short. I'd be over and done in like 5 or 10 minutes. So I decided to add something else. We'll also look at debugging your code in Xcode here. So iAd first, debugging second, so you really get your money's worth. Speaking of money, for more information go to the website hackingwithswift.com, where you can buy this video and indeed all videos from this series as high resolution. And you can also buy them as ebooks starting from just $3, and the books contain lots more hands-on tutorial helpful information to really deepen your Swift learning. Alternatively, find me on Twitter. I am at 2straws. If you have questions, comments, feedback, suggestions, who knows what, follow me, get in touch. If I have time, I'll do my best to help you. If you have random hate or political views, I don't want to hear those. Go and harass someone else. Okay, to get started, go to Xcode. Then choose Create a New Project. Select iOS Application, Single View Application. I'll name mine Project 18. For device, choose what you like. I'm going to go with iPhone just for ease of use. And press Next. Then Create, save somewhere useful. So can iAd be taught in 10 minutes? Yes, it can. Absolutely it can. It's so simple to use. Largely because most of the hard work is done in two places. First, the interface builder, and secondly, iTunes Connect, which is the content management system for app developers. In there, you opt into iAd, and it does all the work for you, figuring out how many ads you've shown and showing the ads and getting you paid and stuff. It's all done through iTunes Connect. And the rest of the other work is done through Interface Builder. There literally is in the object library a banner view. You can go to iAd add and find the banner view and just drag that in, and you've got an ad done straight away. To make things last slightly longer than 5 minutes, I'm going to show you how to create ad banner views in code. This is helpful because very often you'll want to say, hey, just for $1 or $2, we will stop showing advertisements, which people often pay for. So doing it in code lets you have that check and optionally show banners down to you. So go to viewcontroller.swift. iAd is outside of UIKit. It's not part of UIKit. So you must import iAd. Then we're going to declare a variable. We'll hold our banner view. So we say var banner view is a add banner view, like that. Creating the thing is fairly straightforward because they are aware of the device they're running on automatically. So you can use layout constraints to make it fit the view correctly, and it will load the right thing automatically. It's very, very easy to use. So we're going to say in view.load, banner view equals a new add banner view. This takes an add type, which is add type. You will see there's either banner or medium rectangle. Banner being a sort of a longish, not very high banner, the kind of thing you see in websites, and medium rectangles are sort of a large square-shaped-ish thing, largely used on iPad. I'm going to choose banner, like just .banner like that. Then we're going to say banner view.set translates auto-resizing masks into constraints false. This is required because by default it has its own sizing stuff. We'll provide our own constraints to make it place correctly on the screen. And if you do that in code, you must disable this, otherwise the two will clash, you'll have a fight and a crash, and it'll look horrible. We'll also say banner view.delegate equals self, like that. And that will allow us to get messages about when things have happened to the add banner view. We'll need to make sure we conform to the add banner view delegate. So for your class, say class view controller colon UI view controller, comma, add banner view delegate, like that. So we're now a delegate. By default, we'll make the thing hidden because we don't know yet. Oops, .hidden equals true because we don't know whether there is an advert to show or not. Obviously, there isn't always an advert to show. Then we'll add that to add subview, like that. Add that to our view hierarchy so it's visible on the screen. So that creates the banner view, prepares it to be sized correctly, makes us the delegate, makes it hidden by default, and adds it to the screen. Then, if you remember doing the auto layout work in code before, we must make a views dictionary that contains the keys with the view name and the value of the view itself, so we can look it up inside the visual format language. If all this is just completely random words to you, by the way, it means you missed out the tutorial on VFL and auto layout, and you're silly because I told you not to do that. So please go back to an earlier project and find it now. So we'll continue. We'll say let views dictionary equals bracket banner view colon banner view, like that. So it just attaches that object to that label inside VFL. Then we'll say view.add constraints plural ns layout constraint dot constraints with visual format, and the exact VFL is h colon pipe square bracket banner view bracket let me do that again, bracket pipe, which means make the thing horizontally go edge to edge to its super view. Then quote comma like that. Options can just be dot or zeros, metrics is nil, and views is our views dictionary, like that. Boom, done. Vertically, I'm going to copy and paste that line because it's a lot easier. Like that. Let me show the whole thing. There we are, magic. So I'll just change it just slightly. So vertically, we want to not pin it to the top because otherwise it would stretch to fill the whole screen, which looks silly. We want to just pin it to the bottom, so it always sticks next to the bottom of the thing. Again, all zeros, metrics nil, views view dictionary, so that's the only difference you need to do. Change H to V and remove the first pipe. So the iAd banner will now fill the full width of the screen and align itself to the bottom of our view controller. And you know, actually, believe it or not, you're actually almost there, because the iAd banner will do the right thing automatically. It'll talk to the network, grab an advert and show it. But we really do need to adapt to use the protocol to do two things. Firstly, did we receive an advert? If so, we have to make the banner view not hidden. And did we fail to receive an advert, in which case we should make the banner view hidden. Now, both of these are optional, so our code actually compiles and works right now, but it won't do anything because the banner view is hidden by default. So we'll say banner view like this, and you want to look for did load ad. This will be called when the banner view successfully received an advert from the network. This may be called more than once, of course, because it will cycle the adverts. So an advert will be loaded on the screen, they'll see it for maybe a minute or so, and then another advert will be fetched and shown, another advert fetched and shown. So this will be called multiple times. So we'll say banner view, two ends in banner view dot hidden equals false. And if we fail to receive an advert, banner view did fail to receive ad with error, we just want to say banner view dot hidden equals true. Now these two, like I said, can be called multiple times in any order. You might get did load first, then a minute later did fail to receive, then a minute later another did fail to receive, then another minute later did load ad, because it's cycling all the time. So you need to make sure these are working correctly. And crazily enough, that's it. That's all the code required to make iAd work. If you don't believe me, press select your device. I'll choose a iPhone 5S and press run. It'll launch the simulator, and that really is it. That does all the work for us. These add banner views are a very, very helpful view type. You'll see the thing pop up. Boom, loading, 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 and hopefully, boom, add. All animated, all lovely. Tap to learn more, fantastic, tap to learn more, wow. Advert animates in. Contact iAd, I can just swipe through here, then press close. So it's doing all the work for us. That is what the add banner view does. It handles tap detection. It will show its own advert, manage all that for us. It's remarkably, crazily, almost impossibly simple. Now, as you saw with the JavaScript injection project in number 16, when you're working with things that scroll, like table views or text views or collection views, general scroll views, you do want to adjust the content inset and scroll indicator inset properties, as we did in number 16, so that things don't scroll underneath the adverts. That would be quite annoying. Otherwise, that's it. The thing is complete. It even handles other kinds of orientation. See, it stretches to fit the different size automatically. It's really, really simple, and it will auto load the right thing for iPhone 6 and 6 Plus. iAd is crazy, crazy simple. There is one more thing to discuss. which is how you should ensure you only have one iAd visible at a time. So if you're having like a navigation controller where you are pushing and popping view controllers like we had in, say, the very first project, you should reuse the same banner view across the app. This goes into more detail actually in the book version of this project. If you'd like to know more, go on, splash out $3 and have a look at it in the book. So that's iAd. We're done. That's crazy. iAd is so simple that I basically refuse to stop there. We cannot just leave that as a project. We're now going to go on and talk about debugging. So let's zap that project. I'm just going to close that. Then in Xcode, I go to File, New Project, and call this one Single View Project 18B. There is no interesting layout happening here, so I wouldn't worry too much about this. Then Next, then Create. Boom. So there are multiple ways of debugging your code, and I'll kind of work up in complexity. We're starting with the simplest and working to harder ones. I'll choose iPhone 5S again. Doesn't really matter what you choose because it's mostly about the Xcode editor window. So the most basic, absolute easiest, simplest, dumbest way of debugging your code is like the shotgun approach to finding and fixing bugs. And it is the println function we used already. And this we used in the extension, the Swift extension for Safari piece 2 projects ago, to just print out the dump of data received from the Safari browser into the Xcode window. And that's what println does. It just dumps data out so you can read it back. So you might say something like for I in 0 ... less than 10 println number interpolation I, like that, and it will just count up to there. The space there by accident. I'm dumb. It is whinging because I need a closing parenthesis. Boom. And all that'll do is it'll print out number 0, number 1, number 2, number 3, number 4, and so on into this editor back here, so you can see what it's doing. And this is very commonly used inside methods where you've got, func do stuff, and then this calls do other stuff, and func do other stuff is in here, and this calls println other stuff, and it lets you see exactly what your code's doing. It is obviously extraordinarily time intensive because you have to type in these printlns everywhere, and like that. Let's put that actually into a loop. Look at that, tons of prints happening now. Run that back, you'll see, there we go. So it's calling do stuff, which calls other stuff each time. So it lets you visually trace back what your program's doing by adding messages. Your code's kind of talking to you a little bit. Now you'll find tons of people saying how bad this is. It's so messy, it's so unhelpful. And the truth is, it is terrible. It's not a brilliant way of debugging your code. It is just suck it and see. If you've got 50 methods to work through, each of which have loops and if statements and who knows what, then using println everywhere does not make your life very easy. But at the same time, they almost certainly started with it too. They'll start with this, make sure it works, work their way up and do something better. But it's a great starting point just to begin with. One level up from these things are assertions. So let's zap this code. Here we go. Assertions are very, very cool because they are debug-only checks. You see, println, or the older equivalent nslog, this attaches text to the debugging console here, but it will also ship in your final code. If you have, log this, log that, log this, log that in your code, it will exist in the final version too, which is not very good because it slows your code down. Assertions are better because it lets you check for something to be true, make sure this is the case, otherwise print this message, and assertions will automatically crash your program. When you're thinking, well, why do I want to crash the program? That sounds bad. Well, firstly, this is only in debug mode. Assertions do not get put into your final code. They are automatically ignored, which is fantastic. And then you don't mind if the code crashes because it'll tell you why it crashed, which is fantastic. So for a very basic example, we could say assert 1 = 1, maths failure, like that. Oops. Quote end parenthesis. So we're saying, does 1 equal to 1? If it does 1 equal 1, if it does equal 1, then do nothing. If it doesn't, print out maths failure and bail out. We could also say 1 equals 2, which of course is never true. This will fail. So maths failure will be printed out and the code will crash. Let's run it back, you'll see. Boom, crash, bad instruction. Bad instruction, so you'll see, here's an example of a crash and it'll tell you what exactly made it crash, and there are various possible options here. Bad instruction means the CPU received some code from you that it didn't know how to execute. Now remember, when you're writing in Swift, you're writing all this lovely, super voided load and override func, yada, yada, yada. The CPU doesn't actually execute that code, it executes what's called the compiled version of that. So this code gets converted to machine code, to iOS 1s and 0s or whatever, to instructions, and the CPU executes those instructions. Now Swift, of course, when you do a loop, when you do a conditional statement, when you do, functions and stuff, it is not generating invalid instructions, it's generating valid instructions. Otherwise it'd be a very, very bad compiler. You don't want to have bad instructions. So if you see exe bad instruction, for some reason the CPU has been given a bad instruction, and the only reason that can happen is intentionally. Swift has intentionally given the CPU a bad instruction, because otherwise it'd be a bad compiler. And that means assertion is kicked off. So if you see bad instruction, it means something's gone bad on purpose. Now the reason assertions are cool, again, is because they don't exist at runtime in live apps. So when you ship your code to the world, your assertions don't get triggered. So if you had, get rid of this stuff, if you had assert my extremely slow method, equals false, the slow thing returned false, which is a bad thing. That's your assertion, right? If this takes 5 seconds to check, but it's really important to prove that your code works, fine, you can do that in debug, but this stuff will be stripped out when the code ships. It will not run that check, which makes our life much easier. So assertions are like println, but they will auto crash your code, tell you why they crashed the code, and be compiled out when you ship to the world, which is fantastic. Let's go a level up. Let's look at breakpoints. Breakpoints are fantastic. So let's start off with a simple example. For I in 1, ... 100, so count from 1 up to and including 100. We will use println just for ease of use. Println got number, string interpolation, I, quote, parenthesis like that. Oops, daisy, I've got something wrong, like that. There we go, boom. So it'll print out got number 1, got number 2, got number 3, up to 100. Now, if we're having a simple loop like that and we want to see what our program state was, what the value of all our variables was, here, whenever this is called, we can just click in this line number area. Now, if you have not turned on line numbers, you obviously ignored my suggestion at the very, very beginning of this whole thing. Go to Xcode, Preferences, Text Editing, and enable line numbers. This is helpful because with line numbers turned off, it makes it rather hard to place breakpoints sometimes. So it gives you a wider area to click to place breakpoints. So when you click on there, this blue marker appears, and it means there's a breakpoint on that line. If you click again, it becomes sort of a faint breakpoint. Click again, dark breakpoint. So that one is an enabled breakpoint. That one is a disabled breakpoint. It won't be triggered. So you can either choose between active and inactive for your later on use. So with the breakpoint in place, Xcode will pause execution of the program whenever that line is reached, and it will show you the values of all the variables that matter. So if you run this code now, with this is in dark blue mode, it stops and says, here, we hit a breakpoint. And it's pausing this green line. That's the line that's about to be executed. And we can press, go up to the debug menu and choose step over, but you can see it's actually F6. If you're on a Mac laptop, it'll be FN F6, because by default, I think F6, what does F6 do? It changes the backlit keyboard setting as F6. So you need to use FN F6 to step over. But if you look in the bottom left-hand corner here, you'll see it's telling us I is an integer with the value of 1. Self is a view controller. You can open this disclosure arrow to inspect all the things inside it, and you see, well, look, It hasn't got a navigation item. It has no title. All these things are set here, so you can navigate through objects completely and see exactly what it's up to in all these possible situations. Tons and tons of values in there, which is just fantastic to debug with. If you press F and F6, it will advance execution by one line. So it now prints out, it executes a println call and then repeats the loop. Number 2, F6, number 3, F6, number 4, F6. And it steps through line by line by line so you can see what it's doing. You can also press Control Command Y, which is up here, which is continue. And that will go on to the next breakpoint, wherever that might be. Now for us, that is always the same loop again and again and again. So it goes on one line at a time, like that. Now, when your program is paused, what you see on the left here is really, really helpful. This is a program backtrace, bluntly, and it tells you the full section of code that I had to execute to get to where you are right now. So you can see we're currently in view did load. But if we had another method, for example, if we had, again, I'm in that case, if we had func do stuff, which then called do other stuff, then we had func do other stuff, like that, which does nothing at all, let's face it. Println, ooh, brilliant. If in here we actually had do stuff, then we can trace through these various calls. So if I press Command R again to run it back, and then F6, do stuff's called, F6 steps over again. So it's stepping over all the time. But now you can press F7 on do stuff, and it steps into the do stuff method. Here we're now gone into it rather than going over it. F7 again, we're going to do other stuff, and you can now see our stack traces saying, well, this is when you were in view did load, then we went to do stuff, and then we went to do other stuff. So you can kind of work your way back by clicking on these things to see how you got to there. It's a brilliant way to sort of work backwards and see where bugs were triggered. So this is what a backtrace looks like. It's telling us how you got to where you were. That's what breakpoints do. They pause your code at certain positions, but they do two more things. Let's undo this code a little bit, get back to a slightly simpler example. Undo, 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 undo. Fantastic. So we're back to just printing out got number I, got number I, got number I as we go. They can do two more very, very clever things. The first thing is you can make them conditional, which means they can pause your application only if the condition is matched. So right now it'll pause always. Whenever it hits a slide, it just stops. If we right click and choose edit breakpoint, we can add a condition in here, and we can say I%10 equals 0, % being modulo. So it means if I evenly divided into 10 leaves remainder 0, show this breakpoint, trigger the breakpoint, like that. So now we can run this back. What will happen is you'll see in your list down here, it has successfully printed out, strangely blurrily, who knows why, 1 to 9 without any breakpoint. Now it stops because it's going to be 10 next. Press Control Command Y to spin on. There you go, 10 to 19, 20 to 29. So it's doing only when it hits a 10 each time. So it's a conditional breakpoint, which is fantastic because it means you can put in exact conditions and be sure it'll only trigger when that happens, that exact problem situation happens. If your game freezes up when the score is only when it's 0 or 100, whatever it is, you can say make this trigger only if scores 100, which is fantastic. The second thing these things can do for you is so wonderful that you can go to this breakpoints tab up here, and down in the bottom left, the little plus button. If you click that, you can choose add exception breakpoint. Now exceptions are errors from iOS that aren't handled by your code, and they will cause your code to crash. Now, rather than have the code crash and say something went wrong, if you add exception breakpoint, it will automatically stop execution as soon as something goes wrong. So you can examine your exact program state and see what's happening and say, well, oh, I can see why it's going to crash because it's trying to access array index 1,000,000 when we only have 10 things in there. So that is exception breakpoints. The last thing we're going to look at is very, very straightforward, and it's called view debugging. And if you want to open up an example project, you can do. But for now, I'll just literally draw things on the screen because it's a bit easier. So I'll go to my storyboard and I will say I want to have, what should we put in here? We'll put in some buttons, perhaps. Actually, let's just do plain views because we can just color them easily enough. View, actually UI view. There we go, it's a bit easier to filter on. Place it there, make it however big, doesn't really matter how big it is. Boom, look at that. Give it a color so we can see what we're doing. You're going to be this kind of blue color. Let's duplicate that and make it green color, duplicate it again, make it an orange color, or red color, sorry, and duplicate it again over here, whoops daisy, over here. And just spread out views. Obviously you have a much more interesting layout in your code, hopefully, but that's good enough for now. Actually, there's our finished thing. There we go, finished thing. So I'll run that back inside the iPhone 5S. All the breakpoints are off. Now I'm looking at this and trying to figure out, for example, why is this thing not visible? For example, if that orange thing were positioned just so you couldn't see the green thing, I'll move it to the left a little bit, and over there, I can't see the green thing in my layout. I've accidentally put the orange thing over the green thing. Whoops, I am slow, aren't I? Dearie, dearie me, what shall I do? Well, I'll run the code back and I'll say, where's the green thing? I can't see it. And then I will look down to this button here. It's hidden away, and it's not very helpful, but you can find it slightly easier by going to the debug menu and choosing view debugging. This can do a few things. Firstly, it can show view frames. So it will show you on the thing, which we can see that terribly well, thin red lines around your frames, including the main one, showing you the exact dimensions of your stuff. So you can see, well, why is it not positioned correctly? That's why. So it's showing you why. More helpfully, though, is debug, view debugging, capture view hierarchy. This is a crazy, crazy feature because it takes a screenshot of your view, including things that are off screen like that, and makes it, if you click and drag, into a 3D thing, so you can peek behind. And I can now see, aha, there's the green thing hiding behind the orange thing. I'd positioned it incorrectly using this wonderful 3D drag and drop thing. So that is this button here, which is the debug view hierarchy button. And you get this fantastic 3D representation of your canvas, and you can really peek behind and see exactly what it's doing. It is fascinating to use, honestly. If you use like a collection view or a table view, do have a look at the view hierarchy, because you'll see it's very complicated to do basic things. There are a lot of views in there, and you thought there were like, just 2 or 3. There's maybe 10 or so that you weren't realizing even existed, which is just very interesting to see how Apple's own stuff works. So that's it. I couldn't, quite frankly, in good conscience, show you iAd by itself because it's just so easy to use, largely because it's Apple's framework living inside Apple's other framework, so they do most of the work for you. But benefit for you, you did get a lightning fast intro to debugging. There are lots of options to choose from, and I promise you will use all of them, all being well, and that includes even basic sort of shotgun println calls, because you have to start somewhere. Do have a look at this debug menu some more, particularly step into and step out, jumping into methods and jumping out of methods again. There is, bluntly, many ways to debug your code, but if you can just get 2 or 3 of them right, you can forget the other 10 temporarily, because you'll do really, really well with those 2 or 3. You'll get a lot more information than just trying to learn everything vaguely. As a reminder, for more information, please go to the website hackingwithswift.com, where you can buy this video in glorious high-resolution quality, and buy it as an ebook, or indeed any parts of the series of ebooks, at just $3. It's fantastic, super, super cheap. Your support does help me make more videos like this one. It's very, very much appreciated. You can also follow me on Twitter. I am at 2straws. I'll happily help you out to the best of my abilities. And now go debug your programs and have a lot of fun doing so. Remember, there is a very, very famous quote about debugging, that debugging is harder than writing code, which means if you sit down and write code to the very, very best of your ability, you are, by definition, unable to debug it. So be very careful, but try and have fun as best you can.